Okay, so in this video I'm going to have a look at critical path analysis, and in particular I'm just going to have a look at one example here of this set of activities, this project here. Now we're going to have a look at the activities that they depend on and the duration of each one. I'm going to draw a network, and then we're going to have a look at the early and late times for each activity, any flow times that might be there, critical paths. So that's what we're going to do in this video. So this project here could represent anything really. I've got 10 activities here involved in the project, and I have the activities that each activity depends on and their duration. So let's just draw the network first. Now we can see here that A and B, they don't depend on anything, so we'll draw those first, and they have durations 3 and 4, let's say days. So we're going to start with the first node, which we'll call number 1, and we'll draw A and B here. So we call this one number 2 and this one here number 3. This is activity A, which is 3 days. And then we have activity B here, which has duration 4 days. Now if we go back up and have a look at C, C depends on A and B and has a duration of 7 days. So C depends on both A and B. Now the problem here is if we were to draw something like this, we can't put C here and C here. So what we've got to do is just draw one arc from, let's say, number 3 here. We'll call this C, and we'll call this node number 4. And what I'm going to do here is just draw a dummy activity down along here. So now we can see that C here is dependent on B and A. So C has duration 7 days, so we'll put a 7 here. And let's have a look at the next step. So that was C. Let's have a look at D. D depends on C and has duration 2. So D depends on C. So we're going to draw an arc out here, and we're going to call this one number 5. This is D, and it has duration 2 days. Okay, let's have a look at E then. So E here depends on A and has duration 5 days. So E depends on A. It's going to come out here, draw a node. This is going to be number 6. This is E, and it has duration 5 days. Let's have a look at F. F depends on C and has duration 6 days. F depends on C. So I can draw F, let's say up along here, and I can call this one number 7. However, if we look at the precedence table back up here, we can see that G is next, and it depends on E and F, has duration 3. So really what I need to do here is get rid of this and draw a line up along here, draw an arc up here. This is going to be F. It has duration 6 days, and now then when I go to draw G, G is going to come out along here, and G has duration 3 days. I can now see that G, which depends on E and F, this looks correct. So G here depends on E and F. This is number 4, 5, 6, 7. Let's have a look at the next node, H. So we've got H depends on G, and it has duration 4. So H has duration 4. This is going to be number 8. Let's look at the next one. I depends on D and H. So I depends on D and H. So if we were to draw I, let's say I we can put here, which has duration 6 days. I depends on D and H. Well, we have it depending on H, but not on D. So really what we would have to do is put a dummy activity up along here. So now the problem here is, well, not so much a problem, but we have 2 dummy activities. Really I can see now what I could do is just take this node here and attach it here, if you like, combine these 2 nodes here so that D would go directly up along this way. So that's what I think I might do. So let me just go back again. I'm going to connect this one here, number 4, up to here. This is going to be called D. This is activity D, which has a duration of 2 days. Now I need to rearrange my numbers here because I've left out 5. I can't put 5 here because I'm going from 7 to 5. The nodes have to go up in the direction of the arrow, so I can't go from 7 down to 5. So let me just rearrange these. Okay, so there's my D, and this one here was H. This was H, and that had duration 4. And now I've got to do my I. So let's go to I here. This is going to be number 8. This is activity I, which has duration 6 days. So now we've gotten rid of the second dummy activity, and we can see that I here now depends on H and D. Okay, so let's put in the last node then. That is J. So we can see up here that J depends on I and has duration 3. This is number 9, and this is J, and it has duration 3. Okay, so this is our network for this precedence table that I've shown you back up here. Okay, so sometimes when you're doing these networks from a precedence table, it does take 2 or 3 attempts to get where you want to end up. It does take a few attempts to get it right. So from here, where I want to go is I want to have a look at the early and late times for each activity. So I've got to draw this whole thing again, but instead of the nodes now, what I want to put in are boxes, and within the boxes, each box will be divided into 2 sections. The top section will be the early time, the lower section will be the late time. So let's have a look at doing that. Okay, so here's the network again. I've just replaced the nodes with these double boxes. I'm going to put the early and late times in here. So we're going to start with the first one here. It has an early time of 0 and a late time of 0. Well, let's leave out the late time for the moment. We'll work on the what's called the forward pass first. We're going to move from left to right out to the sync node, and we will add in the earliest times that each activity can be completed by. So let's have a look at A first. A is going to take 3 days, so we're going to put an early time of 3 here. If we go down to B here, B is going to take 4 days, so we can put 4 in here. So these are the earliest times that A and B can be completed. So let's have a look then at C. C is going to take 7 days, so we've got to add the 4. That will give us 11 here. We just look up here at E, this part here. We've got 2 arrows coming in here. We've got one from this direction and one from this direction here. So let's have a look at what we would get if we add up the early times and the duration times. So if we add the 3 and the 5, that's going to take 8 days. If we add the 11 and the 6, that's going to take 17 days. So what number do we put in here? Well, G can't start until F and E are both completed. So E can be completed earliest 8 days, and F then can be completed earliest 17 days. So G is going to have to wait for F. So we're going to have to put 17 in here. Okay, so let's move on then. We've got this one here to do. So we've got 17 plus 3, which is 20. That's the only option there. And out here again, we've got 2 options. We've got this one and this one here. So we've got 20 plus 4, which is 24. And we've got 11 plus 2, which is 13. So we're going to take the largest of those 2, which is 24. So 24 goes in there. And then it's straightforward after that. 24 plus 6 is going to be 30. 30 plus 3, 33. So that's the earliest time that the project can be completed, and in fact the latest time as well. Here we're going to put in 33. So let's work backwards now. So this is called a backward pass. So what we're going to do here to work out the latest time that this can be completed is we're going to take this 33, subtract this 3 here, that'll give us 30. Now we're going to move up along this way. We're going to take this 30, subtract this 6 here, that's going to give us 24. Now let's move in this direction here. So we got 24 minus 4, which is 20. And let's move down along D here. 24 minus 2 is 22. So I'm just going to put that here 22 because remember I've got two arrows coming in here. So I'll have a look at that in a second. If I move along this direction again, here we got 20 minus 3, which is 17. And then if I take the 17, subtract the 6, that will give me 11. So what I want to do is pick the least of those two, 22 and 11. So that's going to be 11. Okay, so let's keep going. We've got 11 minus 7, which is going to be 4 here. And then we've also got 17 minus 5, which is 12. So going back to the source node then, we've got 12 minus 3, which is 9, and we've got 4 minus 4, which is 0. So we've got to put in the 0 there. So we've got a 0, 0 here, which is good. Tells us we're on the right track anyway. Okay, so let's just have a look at this. What have we got? We've got an early time, late time here for the project to be finished of 33 days. Now if we look along this path here, so say from here to here, here, even up along here, 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 here. You can see that the early and late times are the same. So that means there's no room for error. If any of those activities are delayed at all, then the final project is going to be delayed. So these are called critical activities. These activities here are called critical activities. And that path there that I've just traced out, this one here, is called a critical path. You'll notice this one here, we've got an early time of 3 and a late time of 12. That means that there is a float time, what we call a float time, of 9 days. So in other words, activity A, the earliest it can be done in is 3 days. It's going to take 3 days to do. But if it's delayed by 9 days, it's not going to affect this here. It's not going to affect the project. It's not going to delay the project. So we can delay this by up to 9 days, and it'll make no difference to how long the project is going to take. So that's just called the float time. The critical path here, by the way, I should say, is B, C, F, G, H, I, and J. That's the critical path. And you can see there's also another critical path. We can go this way, up along this way, down here. And okay, that's it for this video.